Welcome again to another video on circular motion. Today we're going to talk acceleration. More generally, we talked about centripetal acceleration. So let's just briefly review what I mean by centripetal acceleration, and then we introduce another thing called tangential acceleration. Okay, so let's look at something that's going in a circle, because we're talking about circular motion. And so there's a center, and maybe this is going in a counterclockwise. It's going in this way, and it's going at a uniform speed. Means speed is instantaneous speed is same at each point, not just what's the average speed of going on full circle. No, if I ask you how fast it's going over here, you're gonna get the same number. It's over here, over here, over here, at any point. So that's what's called uniform speed. Well, if you look at it, the velocity direction are changing. So the uniform speed does not mean constant velocity. Does not mean velocity is constant, as you've learned. The velocity is not constant, meaning velocity is changing. This means velocity is changing. So the rate of change is the acceleration. And when you analyze it, you find that the acceleration, say if I were instantaneous acceleration, meaning I pick a point in time and say, what's the acceleration at this instant? You'll find that acceleration is pointed towards the center, So is directed, so direction of this is direction towards the center, and has magnitude that depends on how fast it's going over here and the radius of the circle. So a center with magnitude, we use a sub c for it as a notation, and the value is v squared over r. And so this is called centripetal acceleration. So you might say, I can write down the vector notation of that over there. So this arrow represents the centripetal acceleration at this point. This is the point A. Okay, so that's the centripetal acceleration. That's what we did before. Now, we want to address the question, what happens if the speed is not same everywhere? Say it's speeding up, it's going in circle, it's going over here, maybe it's 4 meters per second, over here is 6 meters per second, it's 8 meters per second, maybe 12 meters per second. When it comes back to circle, same place is going 16 meters per second, and so on and so forth. It's speeding up. What happens? Well, of course it's going in a circle, so this is happening anyway, so you're always going to have centripetal acceleration. On top of that, you're going to have the acceleration due to the speed change. So you are going to go, so say the case, is speeding up. So it's speeding up. Slowing down case will be similar, but we're gonna look at just speeding up first. So if I draw this, and I say at this instant over here, so you can, the acceleration now will be, of course you're gonna have the centripetal acceleration, and then because they're speeding up, the tangent to this, if I draw the tangent at that point, tangent to the circle at that point, So this is the direction of the velocity, right? So if it's going this way, this is the direction of velocity. And you're saying the velocity magnitude is picking up. If the velocity magnitude is picking up, then if this was a small, it's going to get larger. So acceleration will be in that direction. So there is some acceleration in that direction. So we can use an arrow to represent how much the acceleration. So this is like a sub c, which we have seen before at this point A. And this will be a sub t for that point. And the net acceleration will have to be made up of these two. So instead of the acceleration being pointed towards the center, the acceleration at A would be pointed somewhere here. That's the net acceleration. So we know the formula for this. If it's going at V and the radius is R, then A sub c has a formula. So A sub c has the same formula as before, v square over r. What's the formula for A sub t? We know the direction. The magnitude of A sub t, so the magnitude, should be how, what is the rate at which the speed is picking up. And that will be how much speed picked up in how much time. Now, if it was speeding up, this would be a positive number. Now, if this is slowing down, then this acceleration should be pointed in the opposite direction. So we'll just call it absolute value and take the direction based on whether it's speeding up or slowing down. So let me write down what will happen in a slowing down case. Slowing down case will be, well, we'll draw again the circle and we just look at the same point A, and so there's a sub c based on just going in circle, and it's going to have the same magnitude and relation. And now A sub t will always be tangential, but it's a slowing down, meaning if the velocity vector is pointed that way, it's getting smaller with time, which means acceleration, tangential acceleration is opposite to the direction of the velocity. So this is acceleration. So we will have A sub c will still be given by the same kind of magnitude formula, but the magnitude of A sub t will be also how quickly the speed is changing. Let's look at an example. Say at this instant, when the say this is a car, when the car is at A, v is 4 meters per second, but delta v over delta t is maybe 5 meters per second square. So it's changing at this rate. And suppose r is equal to 0.5 meter. Then what do we have? We have AC will be v square over r as before towards the center. And that will be just before 4 square over 0.5, and that's going to be 32 meters per second square. But the tangential will be delta v over delta t. Of course, we going to make it positive because this is magnitude. We always think of magnitude as positive number. It's going to be 5 meters per second square. So if I'm looking at this instant, so you can see that this is 5 meters per second square if it's speeding up, and this is 32 meters per second square. So I need to add these two vectors. You've done the addition before, this kind of addition. So this is the net. So this magnitude of net, so the A will be square root of 32 square plus 5 square. You can do the algebra here, and you can figure out this angle to tell the direction of this acceleration. So theta will be some arc tangent. and this is going to be in the second quadrant. You got to be careful with that. 5/32, and you can work out the angle and degrees here. Okay, so I'm going to stop here. Next we're going to talk about in a uniform circular motion, what is the acceleration and force relationship. Acceleration force relationship. And with some examples next time we're going to work out for the uniform circular motion.